I hope I'm audible enough. Good evening, everyone. Today is another day at the PDMP Tech Track. Today we'll be introducing the statistical package for social science and descriptive statistics. Our trainer for tonight is Miss Machi Davis Obodo, right? She's a statistician, a data analyst with experience in statistical analysis, research methodology using IBM SPSS and Microsoft Excel. She has supported students and researchers in analyzing quantitative data and interpreting, as well as interpreting statistical results for academic research. Her areas of expertise include descriptive statistics, hypothesis testing, regression analysis, survey data analysis, and research design. She's passionate about making data analysis simple and accessible. She's into helping beginners build practical skill and confidence while using statistical softwares. Ladies and gentlemen, stand ovation for Miss Machi Davis. Miss Machi, the floor is yours.
All right. Thank you. I hope we can hear me. Thank you very much, Chijuki. That was a very intense introduction. But thank you very much. All right. So I don't know if I'm supposed to show my face, but like the picture is me. I don't change. That's the picture I took like maybe 2 months ago or something, or maybe sometime last. Yeah, earlier this year. Well, yeah, that's me. Okay. So where do we begin really? First, like he said, my name is Machi Davis Obodu. I am a graduate of University of Nigeria, Nsukka. I study statistics. So that's where the statistician came from. And yes, while as a student and even now, I've had the opportunity to do a lot of analysis. I would say mostly statistical analysis, but um, if you start trying to separate data analysis from statistical analysis, then I don't know, it's a very thin line because all of them like lead to the same thing, which is what we're looking for: meaningful information and meaningful results from a bunch of numbers or a bunch of data that we've collected, and that's what everything is leading to. But statistical more so because you are also learning how to interpret this data. That's to give it like not only to have chunk out a couple of results, but to be able to know what the figures are saying. And more or less, that's what our journey in the sessions I'm going to be giving is going to help us to do. Yes, it's important that we understand the package that we're going to use and are able to use it and able to bring out results from it. But more so, it's important that you're able to even understand the results that the package gives you, because um all the things that all the statistical tools or data analysis tool does is that they give you the results. They give you the result. They give you the numbers. They give you maybe extra numbers. Or they give you, so yeah, basically. So now you're supposed to say, okay, what does this number mean? What does this number not mean? What does this number imply? And what am I to do with this number? Which is something that a lot of people find difficult, especially if they've not studied statistics in depthly, because it's in studying statistics that you know what, I don't know, when to reject for example, when to reject a hypothesis, or when to accept it, or and why you should and why you should not, and all those things. But of course, it's a gradual process and it takes a lot of time. And at least so far, what I know so far is that most of the science, for social science, physical science, medical science, and health sciences, they have one or two courses in statistics, which is supposed to help them one way or the other. But sometimes it doesn't do enough. Okay. So after all this talk, yes, basically that's what we're going to be doing, and it would also help you to in the other tools that you also learn to kind of have an idea, like, okay, this is what this means here. Now, SPSS is I think he said it and it was on that flyer, is a statistical package for social sciences. So most times you would people say a lot of things about SPSS. That's the thing. Some people say, oh, it's outdated. So people say, oh, there's no need learning it. You have R, you have Python, you have Excel, you have SQL. So why add SPSS to your knowledge? Like it's just going to take up space in your brain. Um, well, I of course for me to be teaching it means that I don't agree with them. Yes. So um SPSS is a is a statistical package, and the thing about it is that it's very user friendly, right? The interface is very friendly. Like you don't, you of course there's a lot of you put in the work, but at the same time you don't do a lot. So you hardly do any coding really, except you want to do something extra. But you hardly do any coding. It's more like it looks like we'll see it along the line. Looks like your Excel sheet, looks like your Excel sheets, right? So yeah, so it's a user, it has a very user friendly interface, and we'll get to know it, we'll get to see it. So now the issue I had, I was supposed to send Chijoke the file so that you download it before the class so that it's more interactive and more practical, rather not interactive. But I had a problem because um where I had my SPSS, the laptop, like the desktop, and it's in the office, so I don't use it. But my laptop, I was trying to get it into it, and it was a whole hassle. I needed to get it first before I tell someone, "Oh, do this," and it doesn't work. So it was a serious hassle. So that made me to um kind of, we're going to tweak the package we're going to use a bit. It's still SPSS, but it's like how you have Excel and Google Sheets. So you have SPSS and PSPP. So we're going to be using PSPP. But at the end of this class, I will tell you how to go ahead and download it, and also send Chijoke the link so that I can send it to you. Or I'll put it in the chat box so that I can just download it. It's very direct, like it downloads almost immediately. It doesn't have any problem. Okay, so after I've said all these things, I'll share my screen now. Yes. I just wanted to give you a basic introduction, and we can kick off from there. 1 second. Please let me know if you're seeing the screen. Maybe one or two people can just tell me that. And like it's good that you respond sometimes so that I know that I'm not talking to myself. Thank you. But you can let me know if you're seeing the screen anyways.
I can see your screen, ma'am.
Okay, thank you. Okay. I want to believe that other people also see my screen. All right. All right. Thank you. Thank you. Yes, people are answering me. That's good. Sorry, 1 second. Sorry, I'm coming. Okay, so the we're going to go right into it, but I'll just take a very brief poll. So I want to know how many people have ever, okay, maybe I got question. Or how many people have heard of SPSS before today, and what you I've said what I've heard about it and what I know about it. But if you've heard about it and what you heard about it, you can just tell maybe one or two people. I just don't know what you've heard about it, and if you used it, I don't know if you come in contact with it, or if you've seen somebody use it. If Naya, I think you're doing thumbs up, so I guess you have you have an answer to my question. You can just like tell me.
Okay, can you hear me?
Yes, I can. I don't know about others, but I can.
Okay. So we use SPSS during our research times, and basically, yeah, we just paid people to do the analysis and then wrote it in our book that we use SPSS for the research. So I know that it's something that we use when you gather data and you want to actually analyze and get your results. So that was what we used. That's my only exposure to SPSS.
All right. Okay. Thank you, Naya. That's nice. Okay. Valentine, I think I'm seeing your hands up. You can talk.
Okay, good evening, Catherine. Good evening, everyone.
Yes. Good
Okay,
evening.
my introduction to what I know about AS, or how I heard about, if I've heard about SPSS, yes. Just like you guys have said, it's statistical package for the social sciences. I think I know it's a statistical package from, I think, IBM Incorporation, an American technology company, maybe based in New York or among California or something. I think one of the things that I learned about it then is that it has user-friendly interfaces and graphics that can be used for descriptive analysis and evaluations. Like basically, I think in as much as we're the one that did during, just like the forerunner said, we used it during our project work, but it was still someone that um, helped us out with using it for descriptive analysis of our work that time. So yeah, thank you.
All right. Thank you. Was there any other person? Thank you, Valentine.
Okay, I think I've used it before.
Okay.
Like if I already said what it means, but that's long time ago. That's when I did my master's. That's quite a while now. I think I use this to do my data analysis because I use it to do regression analysis. What again? Plots. Some plots. What's this graph again? Scatter plots,
But
regression, correlation, and
okay.
check correlation, and all those stuff. So then I'm not using a brain for anything then. So of course I did my analysis myself. Of course, have check how other works did it. Use the SPS to do my MSc analysis. I think that's my exposure on that. But I forgot most of those things. Yeah. Thank you.
Okay. Okay. Thank you. Okay, so everybody has spoken beautifully well. Yeah, I would say that yeah, most likely, but I think when you see it, you realize that you remember some of the things that you had seen that time because I think that's how our brain works. And of course, when you don't use something very often, you probably not have it very like I don't know at the front of you. I don't know, that's not the easiest thing that you'd come to memory. Okay, and I think Valentine said something about yes, it's having is a user friendly interface and also having good graphics. Yes, that's true. But you might find better graphics some places, some other this thing. But yes, it does have that. And yes. Okay, so great. Okay, so this PowerPoint I have is courtesy of Notebook LM and AI. Like, yeah, so it's not me at all. But I was very impressed when he came up with this. Anyways, but yes, so I'm saying data is basically illuminating the invisible. Those things that we now you correct me when I get it wrong, right? So I need to do a lot of study on radiography to be able to um use the right terms and imply the right things. But I'll try my best today with the little that I know and hope it goes well. But of course, I'll do my research for other classes. Okay, so eliminating the invisible, that those things that we see at the office in the lab, um, I don't know where we take X-rays or I don't know where we do all the things that we do with a lot of ways, that we it can make more sense than it's just I don't know just being there as data. Okay, so a radiographer's guide to data and statistics. So this is one again. Okay, all right. So the clinical data gap requires a precise answer, and I think that's what billions and billions and maybe thousands and thousands of researchers have been doing, trying to find the answer to particular gaps in research or in things that they see in the lab, and they're like, I think this needs to be looked into. I think this needs to be looked into. Okay, so this is a question that we can also answer. So suppose your hospital wants to, or wherever you work, your lab wants to know the average. I don't know whether that's the right terminology to use, but wants to know the average radiation dose for chest X-rays over the last 6 months. What's your answer going to be like? Anybody can answer me. So you can read the question again and try to understand it. But it goes that suppose your hospital wants to know the average radiation dose for chest X-rays over the last 6 months. Over the last 6 months, how would you answer? What should be your answer?
I guess
It's
that should be to take a simple average now of
yes, it's
the
simple
doses,
average, right?
yes, of the doses the patient
Of the
received
last 6
within this
months.
period. Yes.
Exactly. Okay. So that's exactly what and we'll see that along the line, but that's the second part of the class, descriptive statistics. Statistics that just explains your data in the easiest way, the data that you see in the easiest way. So yes, it's simple to you go to the back end or wherever you have your data kept, and you look at, okay, in the last 6 months, these are the amounts of patients that we have and the amount of radiation dose or whatever the data that's collected for radiation dose over this past 6 months, and now take an average. Basically, it's a very simple question. Okay. Great. Okay. So what do you use statistics to do as a radiographer? We said clinical research. It can be used for quality improvement. Sometimes data doesn't really have to be in terms of, oh, I'm doing a research on something related to patients or related to this lab tool or something. It can be, maybe it won't even be you, but it can be somebody in the hospital, maybe in the admin team, wants to know, do we need to do something else to increase the quality of how we see patients or how we interact with people, or the feedback we get from people that pass through this place and everything. Okay, can be used for clinical audits, patient satisfaction surveys, like I said. These days, well, this one is mostly mostly, I don't know whether hospitals do it or labs do it, but I know that most shops, malls, and maybe fintech companies, they always, even WhatsApp call, they take that data. They want you to know or rate. I believe that after this Google Meet, Google is going to send me a message to rate how this Google or something, how this Google Meet went, and do I want to rate the 5-star or do I want to rate the 4-star? That's customers' feedback. But in your case, it's patient satisfaction surveys. How satisfied is patient satisfaction survey? How satisfied are your patients with the way they were treated, or the way they were spoken to, or I don't know how fast the process was. I don't know, different things that people will complain about. And of course, equipment quality assurance, and evidence-based practice. Okay. So statistics is a continuous pipeline, and it moves from, for you guys in the clinical space, it moves from collecting raw data to making decisions, or to clinical decisions, or to valid information. Because sometimes the results you get from a statistical analysis doesn't necessarily end up in you making a decision, but it helps you to stay informed. It helps you to know, okay, this is the situation on ground. I'll give an example, but it's not clinically inclined at all. So some years ago, very few years ago actually, I had interned at an organization in Abuja, and the organization deals with polling. So they take polls of, like, grassroots polls. So they try to see, okay, how well is the government doing? There was a time that there was a very huge wave of food security. There was all this whole thing of food security. How can you improve people's food security? Blah blah blah. All this kind of stuff. So they did a poll on that. And I also think that that particular year they had played AFCON. They also did a poll on that, and it's just those kind of things. So sometimes they don't take these polls because they want to solve a which is one of the things that they do for the record, but they don't take the polls because they want to solve a global issue or they want to solve a national issue. No, they take it so that for information's sake, let's know what people are saying. Let's know, like maybe for the football poll now, let's know which team people are for. Let's know how people think this player is performing at this cup or at this game and all this kind of stuff. Okay, so basically sometimes data ends in mere information, and it's good that we don't always look to make decisions with data that we get. Yes, it's good that we look forward to making decisions with the data that we get, but it's also good to not force your data to give what it doesn't have, right? You don't force the data that you have to, like it happens a lot in research, and well, I think mostly in undergraduate research, because people just want to like do their project and be done with. So they have an idea in their mind, like they want to, let me use one of clinical data that I've worked with. So I think it was MLS, Medical Lab Science. So what did they take there? They take body mass index, different things like that, and ask a couple of questions. And I think the one I did, they were trying to find out they took blood group and I think maybe blood samples to check the now I don't remember the terms, but like all those different components of your blood cells anyways. So yes, so maybe for example the person wants to get the result that women have, majority of the women have 60% of this in their blood, and all of a sudden from the data they've collected they are seeing that 30% of the women from that group of people that they collected that data from that have this 50% of this substance in their blood, just for example. And they're not annoyed, like, no, this is not the result I'm supposed to get. Maybe they even tell me if you help them to analyze their data, they're like, you didn't analyze it well because I'm not supposed to get this result. This research has been done before and I'm just redoing it, maybe, and I'm not supposed to get this result. Now, there are a lot of reasons that could happen. Number one is that the sample data that you're using, the sample population that you're using, or the sample that you're using is different from the one that was used in the previous research. And most times, what we do is that we replicate a research of something done maybe far away from us, can even be done like in another country or in another state. And a lot of things affect people, especially medically. Environment, I think, affects people medically and some other things like that. So if you're going to compare the results that you got from your own analysis with what somebody else somewhere else gets, then you're going to always be annoyed with your results more or less sometimes. And also another thing that would affect it is, what is the sample size? How many people did you collect data from? So now sorry about that. Okay. So I lost my train of thought. But anyways, I was saying that statistics is a continuous pipeline that converts raw data to clinical decisions. And it starts from collecting data, then to organizing the data, to summarizing the data, which is where most times descriptive statistics comes in. Descriptive statistics more or less gives you a summary of what your data is looking like. What's your data looking like? What are the immediate things that you can see from this data? Like for example, in this example that they had given now, maybe someone tells you to do we do all these things practically, but someone tells you to do an analysis of all the patients that a summary data of all the patients that you had seen in the last 6 months, or the patient that has come to the hospital or the lab in the last 6 months. Now, what the person is expecting to do is how many male, how many female, what is their what's their age looking like what's their age bracket, and if they have varying age brackets, how many people are in each age bracket. Um, Sometimes height and weight can be there, something like that. Just what is the data telling you at, not at a glance, of course, because you might not be able to say all these things at a glance because you're looking at numbers, but in the briefest form, what am I seeing when I look at this data? That's what it's saying. Okay, so that's what summarizing data looks like. Then you go ahead to analyze the data. That's where you see something like what I think when you said it, regression analysis, correlation, hypothesis testing, chi-square test. That one, now you're analyzing the data because you're trying to get something out of the data. You're trying to get a result. You're either trying to compare two things, or you're trying to see how this is related to this, something like that. How, I don't know, how yeah, something like that. Anyways, then the next is interpreting the data, which is very important. And like I emphasized in the beginning, it's very important that we know how to interpret data that we get, the data that we get. So data, it's not data, the data that we get, because that's always a problem. Sometimes you might do a very beautiful work, but it comes to interpreting it and you're a bit confused. Okay, then the next is making a decision, or if it's just information, then information. Okay. Okay, so two lenses for viewing clinical data, and we are starting with the one that is highlighted. So two lenses, we have descriptive statistics and we have inferential statistics. Descriptive and inferential. Now, they are just as the name say. I don't know if you can Google it in your English dictionary and you'd see very plain terms for it. But descriptive, like I've been saying, is summarizing the data. What is happening right now with this data? What can I see? And the same thing that when you said, the graphs and the charts, sometimes they tell you this if you know how to interpret them too. They tell, it can even be mode, median, mean. The average is a descriptive data. You're describing the data. You're saying that I had an average of like the average age of the male people I saw this week was 39. That's descriptive data. They are just summarizing what you've seen. And it can be the mean. What was the frequency of the females I saw that came to the lab for an X-ray last month? That's descriptive. Things like that. So, and that's where we are. That's where we're going to focus on. Okay, then inferential is that you use sample data to make predictions, and you want to know what does this mean for everyone else. Predictions sometimes may very far away, but it depends on the sample that you've collected. It can be that you have collected data for people in, I don't know, people in your neck. You want use your sample, your field of study as students.
Sorry, it's because having a network glitch. She's trying to join back.